So now, the stuff that we're going to do now, this is going to be SP47. All right, this is when we do mass to mass problems. And when I was saying that, like, your test and the vast, like your test, like what single topic has the most weight on your grade for the year, it's this, specifically this. All right, and normally I like to break it up, but there's just no, with the way that the weather's going, we got to do this. Endless bells. Yeah, you're good. You have to do both. All right. So let's look at another equation. Here, actually, let's try to keep it really simple for you guys this time. All right, so yeah. Now, this problem is going to involve using the periodic table also. So this is where you can start getting easily confused based on just the way stuff sort of is set up. So first, take a look at our chart here. So our chart implies that we have two masses, mass to mass. And shh, sit down, be quiet. Be quiet. Okay. So you'll notice at the chart, you got mass of A, mass of B. Notice that they are not a direct relationship. When we start involving grams or volume, actually, or particles, even way at the bottom, down there, can even show up down there. It's going to involve more conversions. Now it's going to be using the periodic table, using Avogadro's number, using the molar volume constant of 22.4. We're going to do all that. Today we're just going to do mass to mass. We're going to keep it very simple. But remember that this is from the periodic table. All right, remember, periodic table. Don't forget that. That's the molar masses off the periodic table. So we're going to follow the same steps, but there's just more steps now. All right, there are just more steps, and I'm going to try to outline it as clear as I can, but people can get it confused. So, basic problem. Let's see, what would it say? So let's say if you react, we'll say 28.2 grams of hydrogen gas with excess nitrogen gas. I don't care that I capitalized it after the comma. How much, or we'll say, how many grams of NH3 will be produced? So there you go. That's actually pretty good. That's very straightforward, clear. That's what we want. So all right, if you react 28.2 grams of hydrogen gas with excess nitrogen gas, how many grams of NH3 will be produced? So first, what does the excess nitrogen gas mean? What do we do with N2? Like nitrogen gas, this is excess. That's code for we just don't care about it. It doesn't do anything. Yeah, ignore. So now I suggest you sort of lay stuff out here. So you've got 28.2 grams of hydrogen. This problem wants to know how many grams of NH3 can you actually make with that. Now, the idea here is that this is where you start actually seeing stuff that you would use in actual like chemistry labs and things of actual production facilities. Like this is how you figure out how much stuff can you really make when you mix chemicals together. And we'll do something with this. We're going to make potassium iodide, which is kind of a an interesting thing. Well, not the potassium iodide, the lead nitrate. That's more of the interesting thing. We'll mix it with potassium iodide, and we'll make lead iodide, which is like, it's kind of like lead-based paint from a long time ago, and you'll see. It's fun. But then back to this. The point is, what you want to do, it's actually, you got to look at the chart. So you'll notice there's 4 steps. We're going to start at the mass of A. We're going to convert to moles, then back to mass. This is the longest thing we'll do. You know, it's got 4 steps. I even like to write it out on the paper. Like I'm showing you. I'm showing you everything that I really like. This is how I suggest people do this if they're not sure. And some of you I know are going to not be sure. So you're going to do mass of A. In this case, that's H2. You're going to convert to moles of A, which will in this case be moles of H2. Then you're going to convert to moles of B, which in this case will be NH3. Then you'll convert to mass of B, which again, NH3. So okay, it's, you know, it's a decent bit. So to start with, you just do the very basics. I mean, you're going to have a very long chart written out here, so you know, you might as well. We're going to put it all on one line, so you can't goof anything up. If you break this into individual steps, the chance of error goes up like exponentially because it does. So just do it all in one thing. So 28.2 grams of H2. Huh. Nope. So see, that's the part where it gets kind of, yeah. Oh, you mean right here? Yeah. So we're starting at grams of H2. Now, here you're just going to write grams of H2 down there. It's like one step at a time. So we'll do grams of H2, and we'll be converting to moles of H2. So I'm following along with my little steps. Mass, you know, this is grams. We're going to convert to moles. This is from the periodic table. So remember, this we're going to use the periodic table, the molar mass of them. Just sit down, be quiet.
No, just get in the chair.
Sit on the floor. My back hurts. I'm cranky. Sit on the floor.
Oh, this is Ron's chair. Yeah, I'm sitting on your chair.
Anyway, so the whole idea here, now you've got moles of H2, grams of H2. Now, do we remember, hopefully, how to figure this out? You're just going to say, okay, I've got H. How many H's do I have? Well, I've got 2 of them, right? Because it's H2, so it's going to be 1.01 times 2. I want to make sure you know where every number is coming from. So that will be 2.02, 1 mole. Again, this is from the periodic table. Huh?
Why wouldn't it be 3?
Oh, that's the point. Don't worry, I'm going to explain that. So the next thing, yeah, you look at it and you see the equation and you're like, well, okay, there's 3H2. Why would there not be the 3 there? Because in this first step, all we're doing is we're just converting from grams to moles like we've done previously. I'm answering your question. Pay attention. So the point is, like, you're converting. So this is just like what we did before. This first step is just 1 mole. You're just converting it to moles. Now, in theory, you could put the 3 mole up there, and I found, don't do that. People get it way more confused. Like, don't do it. So just 1 mole, that's it. The next step now will be when you start using the mole to mole, when you actually are going to use the conversion thing. So remember, this is just periodic table mass. This is conversion coefficients in the middle. So now, moles of H2 goes on the bottom. And if there was a part that is most goofed up, it would be this right here. You now have to be like, okay, moles of H2, what am I going to put on top here? Moles of NH3, the new thing. This is the most commonly messed up thing because you got to switch chemicals. You got to switch compounds. It's by far the most commonly goofed up. So just make sure when you do this, you're following your second step. You're using the mole ratio from the coefficients. Just make sure you do that. And then, yeah, so now from the equation, H2 has a 3 in front of it. So there you account for the H2 and the 3. You can only use it one time in your problem. You can't use it in multiple spots. Otherwise, it doesn't work. The moles. So NH3's got a 2, so put a 2 there, right? Questions at this point, like why I'm writing numbers anywhere, what I'm doing. Yeah.
So I say you can only use it once.
You can only use the coefficients one time. And that's why I say put them right there in this spot, and you don't ever include them in any other part of the process. Okay? That's why. What? You sure?
Oh yeah, my 2.
Why'd I write a 2 here? Because in front of NH3, you got that 2. No, that's the thing. It's like there starts to be a lot of stuff to keep track of where it's coming from and whatnot. So okay, so these are coefficients, both of them. So that step's coefficients. And then back to the final step now. So the final step just wants us to convert from moles back to mass. So that's going to be grams of NH3. And if you remember, moles to mass, you're going to multiply by the periodic table mass, the molar mass. So moles will be on the bottom. And this is, now you start to see so clearly why I say you label everything, you write everything down, you write your units down. It's so much clearer. It's so much faster and easier to do. If you're just writing random numbers here without units, you're going to get it wrong. I don't care how smart you are, you're going to get it wrong. And then you'll put grams of NH3 up here. So then last but not least, you figure out the mass. So 1 mole, you look up NH3. So we've got NH3, we've got 1 N, we've got 3 H's, that's 14.01,
So 16.3.
1.01. So you're going to add those up. That'll basically add up to, what'll that be? 17.04, right? So everybody got that? Like, we're good? So again, that number is from the periodic table. All right. Then you just do all the math. And that, I suppose, is probably the second most commonly goofed up thing, is people set it all up, but then they just, goof up the division or something. Don't do that. You can cancel everything out to make sure that you are left with just the thing. Like, those cancel, those cancel, those cancel. If they don't cancel, you did it wrong. And you want to go back and fix it. So now, just to make, as if we're not sure, let me remind you how this will work. Yeah, so you'll do 28.2 times 2 times 17.04. Multiply everything across the top, and then I just divide by everything on the bottom, ignoring the ones. Okay? What do you mean? I did 28.2 times 2 times 17.04. Hit enter. Then I just hit divide by 2.02, divide by 3. I like to do that because it avoids any potential source of light. If you were to divide that and then you're saying that's a time sign right there, that'll goof up the order of operations. You would have to do 2.02 times, you'd have to do it inside the parentheses like that, otherwise it won't work. Because otherwise it divides by 2.02, then it timeses everything by 3. So you get 158 point, I'll say 59. We'll just keep it like that. We're not going to worry about significant figures, which is, you should, but then, since this is not AP, we're not doing that. And to be clear, in the notebook, on your test, whatever, this entire thing, all of this, that's what's required, minus periodic table and coefficients and stuff. It's a lot. I know, I told you, there's a reason I said this is I was serious. This is a lot of stuff. This is where it goes from being kind of funny to oh, this is, we have to do chemistry now. So, questions? We really don't have questions. I don't believe any of you, but let me